Yes, grade 12s, how are you today? My name is Patrick Kamala. I'm a tutor and educator for mathematics and physical sciences here at Lost College Polokwane. Today we are doing calculus video 2. If you enjoyed our first video, please you're gonna enjoy this one here as well. Now at Lost College Polokwane we do extra classes, also do metric upgrade. So you can either come and attend at our site, our center, or you can attend online. For more information, you can contact us on 0785 222 Let us start. Today we're looking at calculus part 2, and this is video 2. We're going to look at specifically the cubic function. Don't forget in the video we said that this calculus, it covers approximately 35 marks out of paper 1, so it needs enough time for us to do it correctly. So how do I teach it? Calculus part 2. Let us start. Now we're starting with a cubic function. Now a cubic function it can be written in 3 forms. It can be written in the standard form as you see it here, that is ax cubed plus bx squared plus cx plus d. All can be in a turning point form, that is a into x plus b1 squared, then x plus b2, okay? All can be in the intercept form, whereby b1, b2, and b3, they are the x-intercepts. In that case, going to be y equals to a into x plus b1 into x plus b2, then x plus b3. Okay, now a cubic function can look like any of these ones here. Have a look at this. So we can have our cubic function like this. Okay, it can be like this, having first of all a maximum, then minimum, then it goes up. Or it can only be ever increasing like this, as you see it here. Or it can be first of all decreasing, and then increasing, and then decreasing. Or it can be ever decreasing for x values. Okay, so these are the cubic functions which we expect to look at today. Okay, now let me explain again. So if we have the turning point form, like in this case y equals to a into x plus b bracket squared into x plus b2, turning point will mean that is where we have got a square here. It means that our cubic function is going to be turning at this b1 on the x-axis. Okay, check this one out. So in this particular case, for example, here as you can see, my function is turning at this point here, For example, if I have something like, let me say, if this is going to be, let's say if this one is 2, okay, and this one is going to be, let me say negative 1, okay, so my function is likely to be y equals to a, okay, into x plus 1 because of the minus 1, then brackets into x minus 2 because of the positive 2. But because it is turning here, we're going to say here it's going to be what? It's going to be squared. Hope we are together. So that one gives us a hint of what we're looking at. Or it could be like this one here. Check this out. This one here. Again, as you can see that it is turning here at this point here. So for example, if I have my values here like this now, let's say if here this is positive, let's say if this is positive 2, okay, and here this is positive 4. So in this particular case, my function f of x would be f of x equals to what? Equals to a, okay, into x, this is positive 2, then minus 2, x minus 2. You see it is turning at 4, then x minus 4, but it must be what? Must be squared. We're at 4 because it is turning here. So when the turning points on the x-axis, that root, like this 4, we must put a square in our equation at that point. Hope we are together. Now if you check our cubic functions, all our cubic graphs, the way they look like, we can analyze them. But before that, again, we can have the intercept form like here. This particular case, check, I could have my b1. If my b1 is this value here, if this is my b1 here, let's say if this is 1, okay, this point here, this is 1, then this point 2, this is 3 if this one is 5. Okay, so now it's called the intercept form. These are called the roots. Like now at this root something, note that at that root our f, if this one is our f of x, our f of x, it is equal to 0 at these points here. That's why you can say y equals to 0, or you can say f equals to 0. So these are called the roots. So in our equation, for example, in this particular case, because I have the intercepts 1, 3, and 5, it means that my function might look like this. Okay, it would be like my f of x. Okay, my f of x equals to, this is the first intercept, it's going to be a. Now a is a constant which we get because of the shape of the function, so it's going to be x minus 1. Okay, x minus 1 because of this one here, all into x minus 3. Okay, because of this positive 3 here, all into x minus 5. And then if I have any other point on the function known to me, then I can find the value of a, and then I'll be having my what? My cubic function in this form, which is the intercept form. Now let us analyze this cubic function in detail, because it's very important for us to know the shapes. Now this shape, as you can see, it's first of all looks like this. Okay, another shape could be like this one here. Another shape could be like this one here, whereby it is first of all, let's do it here together, check it out. My other shape could be like this. Okay, it will come like this. Now these are the axes here. It will be like, let me use a different color now. Let me use I think blue. It's gonna work. Now my other graph will look like this. Check. Would come here. Okay. I beg your pardon. It's been like this. It would come like this now. Check. Come here like this. And like this, and then now like this. You see, so in this particular case, I have this intercept here, the x-intercept here, this one here, and this one here. So now this shape, together with this other shape, which you see here now, you see that they're different. This one is good, goes like this. Now, if I combine these two shapes, I can come up with a summary, which looks like a fish. Okay. Now this A, which you see in here, this A, it tells us the shape of the what? The shape of the cubic graph. If our A is bigger than 0, then the shape would be like this one here. I repeat, if the A is greater than 0, then the shape would be like this. Okay. However, if my A is a negative, that's 0, then the shape would be like this one here. Okay. Now these two shapes, if you combine them together, you can come up with a fish, just for you to remember the shapes properly. Let's check them out here. Now if you look here, if my a is bigger than 0, like this is 3x cubed minus 5x squared plus 10x minus 20, and here it is less than 0, so negative 5x cubed plus 4x squared minus 2x plus 10. Now come check this out. If I happen to bring this shape here, this one, okay, and then I put closer to this one here like this, as you can see that my shape looks like a fish now. Okay, so now this one, note that is when a is bigger than 0, so our shape's like this, and when a is less than 0, our shape's like this one here. So in case you want to remember, then this is what you should do. Okay, so in this particular case, if I happen to come up with something like this now, okay, let's take it back this one, and then I come up with something so important here. So if I get a copy and take it back here, yes, now this one also, so this one I have it now, look at this, okay, just put it here, and then this other one also get a copy here, and you see, then I bring it here. Now if you check here, I'm forming something like a fish. Okay, now to know which one is which, what we do, our fish here has got a mouth. Okay, it has got what? A mouth. So if I do like this now, I beg your pardon, let's use the pen. I do like this now, check. Like this. Now I can put my 0 here. My 0 here, meaning that in this particular case my A is bigger than 0. So the shape will be like this. Are we together? I repeat, my A, the A, like in this case, 93, 2, and any number here bigger than 0. So my shape for the function will be like this one here, which you see here. Then, however, if I put something like this now, theoretical now here, if my A is less than 0, like in this case, okay, I'm going to put my A here now. Now this is less than 0. So here our A is less than 0, so our shape will be like this one here. So it will be the shape of the cubic function. So that's why you see it here like this. Okay. All right. Now let us look at how we solve the cubic equations. First of all, what the cubic equations? Okay. Now a cubic function again it has got what we call as two turning points, or can have only one point of inflection, like we saw where it is ever increasing or ever decreasing, and also note that the derivative of a cubic function yields a parabola, which we're going to see in our next video. Okay, now these are the steps for sketching or drawing the cubic function. First of all, A shows us the shape, like we said. It can be less than 0, like this. Then next, we find out to call as the turning points. The turning points, that's stationary points. Here it's a turning point here, another turning point here. Turning point here, another turning point. So how do we get them? We differentiate. After differentiating, then equate to 0, and then substitute back the original to get the y values for the turning point. I repeat, to get my stationary points, what do? I differentiate, equate to 0, and then back substitute to get my y values. Now today I want us to look at how to solve the function. Now to get my y-intercept, I let x equal to 0. And about x-intercept, I let y equal to 0. Okay. Now today I want us to look at how to solve the x-intercepts. Okay. So what we do here, you determine the factor, that's the number that will make equation equal to 0, and then determine the coefficient of x squared, and then the constant by inspection, and then determine the coefficient of x by equating the coefficients, and then factorize the quadratic factor to obtain other factors, whereby sometimes you can use what? The quadratic formula. Now in these examples, I'm going to explain in detail how we do this, okay? For example, they say here, determine the x-intercept in the following equation, that is a, b, c, and d. So we're starting with fx equals to x cubed minus 4x squared plus x plus 6. So we're going to determine the x-intercept where the function is cutting the x-axis. Now at the x-intercept, note that those x values, we call them roots. So here, this one is a root, 3 is a root here, and 5 is also a root. Okay, let us continue. Hope we are together. Now, for example, here they say solve fx equals to x squared, x cubed minus 4x squared plus x equals to 6 plus x plus 6. This is our function here. Fx equals to x cubed minus 4x squared plus x plus 6. So I want to show you how to get our intercepts. Are we together? Where we're going to equate to 0. So what do we do in this case? Watch this. Now, first of all, we look for the factors, whereby when we put in our function, they give us 0. If they do give us 0, then those x values, we call them roots. Okay, so in this particular case, if I begin with the positive 1, f of 1, if you check here, if I put in my calculator, I happen to get positive 4. So because the 4 is not a 0, it means that x equals to 1 is not what? Is not a root. It's not a root. Okay, so for that matter, x minus 1 is not a factor as well. Now if I happen to put in if I happen to use now my negative 1 in my functional origin again, what happens now? Check here. If I put negative 1 here with my calculator, I'm going to get 0. Okay, so after getting 0 now, because I have a 0 here, that means at x equals to negative 1, the function is cutting the x-axis, and therefore negative 1 is one of the roots I'm looking for. Okay, so it means that in this particular case, x equals to -1 is a root. So that's one of my answers that I'm looking for. Now note that any cubic function can be written as a product of the linear function, that's the factor which you get from here, and then the quadratic function. So here, if x equals to -1, -1 becomes positive this side. It becomes x plus 1 equals to 0, and therefore x plus 1, we call it a factor of our function. So x plus 1 is what? Is a factor of the function. So now my original equation, I can write it like this now. I can write it as like this now. That is the linear factor which you see here, and the quadratic. Okay, so in other words, my x cubed, okay, this x cubed minus 4x squared plus x plus 6 is the same as x plus 1 multiplied by ax squared plus bx plus c. So my task and your task is to find the value of a, value of b, and value of c. When we are done, we can solve the quadratic equation. Okay, we can solve the quadratic equation whereby we can either factorize or we can use the quadratic formula. Now, note something here that to begin with, because this is 1x cubed, and I can see this was x into ax squared, so I can only get x cubed by multiplying x times ax squared. So because I must get positive 1x cubed, it means that my a has to be positive 1. Why? Because if I multiply x times 1x squared, I'm going to get what? I'm going to get x cubed. So that's why I put 1 here where there is a. I repeat, x multiplied by 1x squared gives me what? Gives me 1x cubed, meaning that putting a positive 1 here, it is wise and is correct. Okay, let us proceed. Okay, and then now I continue. I go ahead. I need to find my c. Now to get this c here, what I do, this constant here multiplied by c must give me the same constant this other side, which is positive 6 in this case. So how can I get positive 6? By multiplying positive 1 times positive 6, meaning that my c is going to be 6 as well, because 6 multiplied by positive 1, indeed I get positive 6. That's why I put a 6 here. So now my task is to find b, because I have the a and the c. Now watch this now. Now to get my b, what do? I come here and I check, I compare coefficients of x squared. Now this is -4x squared, as you can see it here from the cubic function. Now this side, how can I get x squared? If I multiply x, this x times bx, I get what? I get bx squared. And if I multiply 1 times 1x squared, also get x squared. So in other words, if I combine the 1x squared plus bx squared, that's the only way I can get x squared. So if I put them together, the coefficient of x squared, and I have something like this now. So I'm going to say here -4 is the same as 1 plus b. They are all coefficients of what? Of x squared. So if we check properly here, we can see that the coefficient, whereby in this case it is -4, this -4, right? This -4 here is going to be equated to the other coefficient of x squared from the other side. Okay, so I'm going to say -4 equals to 1 plus b, and then I can solve my b in this case, because I'm going to say that -4 equals to 1 plus b. So what's going to be my b? It's going to be b equals -5. And once I get the b, then now I can go ahead and solve my what? My quadratic, because I have the a, the b, and the c. What is our b here? It's -5. Why? Because -4 minus 1 gives us -5. Let us proceed here. So after getting the A, B, and C, like I said here, you go back and substitute. So mean that our original cubic function, this one here, is the same as writing the linear, that is x plus 1, into x squared minus 5x plus 6. Okay, now to solve this one here, you can look for the factors. Two numbers, multiply, get negative 6, positive 6, and when you get negative 5, those numbers are negative 2 and negative 3. Check it out. Negative 2 times negative 3 gives me positive 6, but negative 2 plus negative 3, I get negative 5. So these are the factors here. So know that I was solving for x equals to 0, fx equals to 0. So meaning that in this particular case, I can either have my answers like this. I can say either x equals to negative 1, that is from here after equating to 0, or x equals to positive 2, which comes from here, or x equals to positive 3, which comes from here as well. So that's how we solve this equation. We have another example, don't worry about it. Let's continue, check it out now. Now if I want to solve, for example, this one here, they say solve for x if fx equals to 0, and they gave us this equation here, that is fx equals to 6x cubed minus 11x squared minus 3x plus 2. We are solving this one by equating it to 0. Okay, so what do we have here? Now if I put in x equals to 1 in my function, what do I get? If I put x equals to 1, check that I'm going to get 6 1 cubed minus 11 1 squared minus 3 times 1 plus 2. It gives me negative 6. So negative 6 being not a 0, it means that x equals to 1 is not a root, and therefore x minus 1 is not a factor. So x equals to 1 is not what? Is not a root, and so x minus 1 is not a factor as well. So I continue trying. I'm going to use negative 1 and see what happens now. If I put negative 1, unfortunately I still don't get 0, but I get negative 12. So again it means that x equals negative 1 is not what? Is not a root, and neither is x plus 1 a factor. So I proceed and try something else. Okay, now if I choose another x value, and let's check it out. If I choose this one now, which is x equals to negative 2, still I get negative 84. And for that matter, again, x equals to negative 2 is not a root, so therefore it means x plus 2 is not a factor, so I can't proceed with that. So I take another choice now. If I use here, this was x equals to negative 2 is not what? Is not a root here. Okay, it's not a root because you see that negative 2 did not give us 0. Okay, so but however, if I put now x equals to 2, check this, we see that I have 6 into 2 cubed minus 11 2 squared minus 3 times 2 plus 2. I get 0. So because I get 0 here, it means that x equals to 2 is a root, and therefore x minus 2 is a factor. So after getting my linear factor, I go ahead and rewrite my story, and I'm going to say that in this case that my x cubed minus 11x squared, so the 6x cubed, you see this here, 6x cubed minus 11x squared minus 3x plus 2, the same as writing the linear factor, which you got here as x minus 2 multiplied by the quadratic expression now. Okay, so let us continue. So after writing it like this now, my task is to find the A, the B, and the C. How do you do that? Now the A and the C, get them by inspection. Now if you check here, you can see that this is 6x cubed, which you see here. So because here I have got x, and this is ax squared, it means that x times, I want to get 6x cubed. What do I put here? Where is a here? I'm going to put 6 because x multiplied by 6x squared gives me what? Gives me 6x cubed. Therefore, my a is going to be 6. That's why a equals to 6 here. I repeat, if I say x multiplied by ax squared, I'm going to get ax cubed. So, but because this one is, the coefficient here is 6, so I must put 6 here. So that however, after multiplying x by 6x squared, I'm going to get 6x cubed. So my a equals to 6. Hope we are together. Let us proceed. Then, if I look at the constant here, it is positive 2. What about here? I have got a c and a negative 2 here. So for me to get positive 2, I must multiply negative 2 by negative 1. So if I put negative 1 here, I can say I can get my positive 2 back here. So therefore, my c is going to be negative 1. That's why I get my negative 1 here to be the c. Hope we are together. There I'm comparing the constants. That positive 2, how do I get it this side? That was given to me. Then side I have got negative 2 multiplied by negative 1 to give me positive 2. So my c equals to negative 1. Hope we are together. After getting the a and the c, now I write my function like it's going to be 6x cubed minus 11x squared minus 3x plus 2 equals to x minus 2 into 6x squared plus bx minus 1. Okay, so what do I do here? Now I find the value of b by using coefficient of x squared. So if you check here, this is negative 11x squared. That's why I put it here all together. How can I get x squared this side? I have x multiplied by bx, it gives me bx squared. Also negative 2 multiplied by 6x squared gives me what? Gives me negative 12x squared. All together. So this negative 11x squared, what about this side? I have what? I have bx squared minus 12x squared. So if I take out the x squared, okay, and I write it like this now, take x squared out here, I'm going to be having b minus 12. So if I compare the coefficients of x squared, I'm going to equate b minus 12 to what? To negative 11. So the minus 12 becomes positive, right? So I'm going to say that negative 11 plus what? Plus 12 must give me what? Must give me b. Okay, so for that matter, after simplifying here, what's negative 11 plus 12? I get my b as 1. I get what? My b as 1. So after getting b as 1, then I go back in my and I substitute. So where I was having b, I put positive 1 here. So now I'm solving x minus 2 into 6x squared plus 1x minus 1 equals to 0. So now here I can use quadratic formula, or I can use the cross method to solve this one here. I repeat, I can use the quadratic formula, or I can use what? The cross method to solve this one here. So either x equals to 2, because of the 0 here, or now this cross method, this is how it works here. You do it in grade 10. Let me just remind you what we do here. So what you do, the 6 which you see here is what you see here. The negative one, we put it here, then put 1 here and 1 here, because 6 times 1, I get 6. Negative 1 times 1, I get negative 1. Okay, so what we do, we cross these vectors. Okay, so 6 times 1, it gives me 6. 1 times negative 1, it gives me negative 1. So if I add the two answers like you see here, I don't get the middle term, which is positive 1. So mean that this is not the right choice to use. So what I do, instead of 6, I write it as what? As 3 times 2. What about this one here? I don't change it. So if I do so now and write 3 and then the 2, I can see here that if I cross again, I'm going to say 3 times 1, it gives me 3. What about 2 times negative 1? I get negative 2. So negative 2 plus 3 gives me positive 1. So because I have the positive 1, which is the same as the middle term here, and that is one of my factors here. So meaning that in this case, to get my answers, watch this. What do? You just put x here and here like this. Okay, I just put x here. So it means that my factors are going to be 3x minus 1 multiplied by 2x. This is positive 1 then plus 1. Okay, so that's why I have here 3x minus 1 into 2x plus 1. So with the other factor, which was x minus 2. So after equating to 0, like I'm commanded to do, I can set my answer to be x equals to 2 because of something here, and x equals to 1 over 3 from here. Also here x equals to negative 1 over 2 from here. Another example. Hope we are together. Let's proceed. Now again they say solve for x if fx equals to 0. So I first equate to like this. Now I'm going to choose numbers again to see which one gives me 0, like we said before. So if I try in and I put negative 1, I don't get 0 but I get 6, so I proceed to try. Now if I try and put positive 1, fortunately I get what? I get 0 here, as you can see. So because I get 0, that x equals to positive 1 is a root, and x minus 1 is going to be a vector. So because I got 0, x equals 1 is a root. What about my vector? It is x minus 1. Okay, so now I rewrite my what? I rewrite my thingy, my expression again, like this now. Okay, I'm gonna say now that the x cubed plus 5x squared plus 2x minus 8 equals to the linear factor, which is x minus 1, then times the quadratic expression, which is going to be ax squared plus bx plus c. Now explanation again. Because here I have 1x cubed, how can I get x cubed? This is by multiplying x times ax squared. So mean that I have to multiply x times 1x squared because I want to get 1x cubed. Okay, so meaning that my a is going to be 1 definitely, because x times 1x squared gives me 1x cubed. Okay, therefore a equals to 1. Then to get my c, as you can see, I've got a negative 8 here and a negative 1 here, which means for me to get negative 8, I must have my c to be positive 8, because positive 8 multiplied by negative 1 gives me negative 8 here. That's why we said here that negative 8 equals to negative 1, this one here, multiplied by 8. So my c is going to be positive 8. After getting a and c, I have to get my b. So I first write it like this. Now I'm going to say that x cubed plus 5x squared plus 2x minus 8 equals to x minus 1 into 1x squared plus bx plus 8. So my task now is to find the value of b. Okay, so what do I do here? Now if I look at here, I have 5x squared this side. What about here? I can say x times bx to get my bx squared, or I can say negative 1 times x squared gives me negative 1x squared. So now if I take out x squared here and I compare the coefficient of x squared, I'm going to say that 5 equals to b minus 1. I'm going to say that b minus 1, I can see, I'm going to compare it with the 5. So because these are x squares, all of them, I can equate the coefficients by saying that 5 equals to b minus 1. Okay, so now the negative 1 becomes positive to give me 5 plus 1 equals to b. And then after getting b as my 6, I go back and write my expression again. After doing so, then I can equate to 0 and either factorize or use quadratic formula. So as you can see here, I have the a, b and c. But fortunately here I have got the factors, two numbers, multiply, you get positive 8. When you get positive 6, we have got what? We have what? We have negative 2 and negative 4. Okay, we have negative what? Negative 2 and 4. Let's check properly something here. Okay, let's all be there. Alright. What do we have here? x minus 2, x minus 4. If I multiply, I get positive 8. What about when I add? I don't get positive 8 here. And I get negative 6 instead of positive 6. So it means I have to do this one again. Okay, let's check it out here. So if I do so, okay, oh yeah, let's check it. This one must be negative, which is fine here. So what happens here? Let's use quadratic formula. Okay, we have the factors here which give us 6. I need positive here. B squared minus 4ac. Let's check it properly here. So let me just review. Let me review what I did here. So if I have what? If I have, okay, no, so I just have to correct it here like this. Check this out, guys. So in here, let's bring back my pen here. It's going to be plus here, must be positive here. Positive here. Why? Because positive 2 times positive 4, I get positive 8. Okay, and positive 2 plus positive, I get positive 6. So meaning that I have x equals to 1 and x equals to negative 2 as my answer. Also x equals to what? Negative 4 as my answer. So these are the solutions here. Hope we are together. Then do I have another example? Okay, I had one more example here. Alright, that is it for that. Now this method, as you've seen, it is a little bit longer. We have got a shortcut here. Now the shortcut here, I call it a game changer, which is a method 2 of solving cubic functions. It's called using the synthetic division. So they say here, for example, solve for x if fx equals to 0 in the following equation here. So we have fx equals to x cubed minus 4x squared plus x plus 6. Okay, so we want to solve it using the synthetic division, which is a little bit shorter than the previous method. So I want you to pay attention here, please, as we do this. Okay. Okay, now check this out. First of all, choose my pen here. I'm going to use a red color. Now we see this is a function here. So if I put in negative 1, I get 0 here. So because I get that x equals negative 1 is a root, one of the roots I'm looking for, I write it here the way it is. I write it where? I put here negative, this negative 1, I put it here the way it is. That's negative 1. Okay. Then from there now I put the coefficients of my cubic function. This is positive 1 here. I'm going to say positive 1 here. Okay, positive 1. And then followed by negative 4. I'm putting the coefficients, negative 4, followed by positive 1, okay, here, and then I have positive 6 here, Now I repeat, after getting 0, I get my root, then I put it here, that's why it's negative 1 here, altogether. Then I write the coefficients on this back L, this is L written backwards. I begin with the x cubed, which is positive 1 in this case, then negative 4 here, and then positive 1 here, and then positive 6. Now this is how the method works. First, what you do, whatever is here, you bring it the way this is 1, so you're going to say positive 1 here, okay? So what you get, the positive 1 here now multiplied with negative 1. So what is positive 1 times negative 1? So positive 1 times negative 1, it gives us what? It gives us negative 1. So what you get here, then you edit here now. So here I have negative 1, okay? Then after that I'm going to add negative 1 plus negative 4. What do you get? I get negative 5. Okay, negative 5 altogether. Then I'm going to say again negative 5 multiplied by negative 1. What did you get, guys? I say negative 5 multiplied by negative 1. What do I get? I get positive 5. I get what? Positive 5. So the positive 5 now, which I get here, I'm going to add it here. So yes, a plus 5. Okay. So when I add positive 5 plus 1, I get positive 6 here. Okay. Get positive 6. Now again, I'm going to say positive 6 multiplied by negative 1. So positive 6 multiplied by negative 1. What do we get here? I get negative 6. Okay, so what I get here is negative 6. Then now I'm gonna come and add it here, so it's gonna be negative 6 here. Okay, now negative 6 plus 6, I get 0. The moment you get 0 here, it means you are correct. If you get something not 0, it means you made a mistake somewhere. So now these are the coefficients of the quadratic expression. So mean that I'm now gonna be solving x plus 1. Okay, and write it properly now. I'm going to be solving what? Okay, this now. I'm going to be solving x plus 1. Remember, my first root was x equals to 1. Eh? So it's going to be now minus 1. It's going to be now x plus 1. So I have x plus 1 multiplied by, again we said ax squared plus bx then plus c, okay, equals to 0. Now my a is positive 1, my b negative 5, my c positive 6. So I'm going to say now I have what? I have x plus 1, into our a is what? Is 1, so that's going to be x squared. Okay, what about our b? Minus 5, so minus 5x. Okay, what about our c? It is positive 6. Okay, equals to 0. Okay, so now in this particular case, as you can see, if I happen to factorize here, I'm gonna get, so it's already x plus 1, so x plus 1 here, then into, what are the factors here? Between positive 6, I've got negative 2, and negative is going to be x minus 2 into x minus 3 equals to 0. So mean that in this particular, what are the answers here? I have x equals negative 1 as my first answer before. Then from here, x equals to positive 2 as the other answer. Okay, then x equals to positive 3 as the other answer. That's how we solve using the synthetic division method. Okay, now another example here would be like this. Now another example here which I have. Okay, now again here they said solve for x in the following equation here. So again, like you saw before, this is my equation here. If I put in 2 here, I get 0. So what do? I mean that positive 2 is a root, right? So I get that root and proceed like we did before. So I'm gonna do like this now. I'm gonna put, this is the positive 2, I'm gonna put it here. Okay, so I'm going to say here positive 2. So here I have what? Positive 2 here, positive 2. What about the coefficients here? X cubed, I have what? I have positive 6 here. So this is positive 6. That's for x cubed. Then I have negative 11. That is for x squared. Then I have negative 3. That's for x. Okay. What about my constant? I've got positive 2. Okay. Now note that if I didn't have anything for x squared here, I was going to put 0 here. Okay. Alright, now we said that what you do, the first one, write it to the way it is positive 6, write it to the way it is there. Okay. And then multiply by the factor, by the root. So what is 6 times 2? What is 6 times 2? What is 6 times 2? 6 times 2, it gives me what? It gives me 12. positive 12. So what I do, then I come and add positive 12 here. I'm going to say plus 12 here. So plus 12 here. So 12 plus negative 11, you get what? You get positive 1. So positive 1 comes here now. Again, multiply positive 1 times 2. So 1 times 2, what do you get? 1 times 2, we get 2. Okay, so now the 2 which you get, you're going to add it here. So plus 2 here. Plus 2 here. 2 times negative 3, I get negative 1. Times 2, negative 1 times 2, I get negative 2. What do? I put it here, negative 2. Okay, so negative 2 plus 2, I get 0 now. Okay, so meaning that now I'm solving what? I'm solving my expression as the first one was, this was my first answer. So together with this other one, which is quadratic, which says this is going to be now 6x what? 6x squared. Okay, and then plus x, and then minus 1 equals to 0. Okay, so what do you do here? Already we saw the factors. I think, remember them, we saw it was 3 and what? 3 and 2. Okay, so it means that I have here, I have the 3x, okay, and then also the 2x here. Okay, because I want to get negative 1 here, it must be plus 1 then minus 1. Okay, because I want to get yes, must be plus 1 here, plus 1 then minus 1, because 3x times negative 1, I get negative 3x. What about here? Yeah, I think I solved them. Must be minus here then plus here. Okay, so it's gonna be minus here then plus here. So from here, after getting to 0, what are my answers now? I have the first answer was x equals positive 2, which you see up there, x equals to positive 2. Then x equals to positive 1 over 3. Also x equals to what? Negative 1 over 2. That's my method there. Then another one here, another example, just to make it clear. Again, let's solve here again. After getting 0 here, again what you do, if you put the root here, like we said, this is positive 1, I'm going to put it here, and so like we just discussed before. So I put the positive 1 here. Okay, I put the positive 1 here, put the positive 1 here. What are the coefficients? This is 1, that's positive 1 there. What about x squared? That's positive 5. Okay, and then what about here? This one, it is positive 2. Okay, then we have negative 8. Okay, so we said the first one, bring the weight. This is positive 1, write it the way it is, that is 1. Now 1 times 1, I get 1, so I add it here. I say plus 1 here. 1 plus 5, I get positive 6. Now I'm going to say 6 multiplied by 1, I get 6, so I add 6 here now, so plus 6 here. Okay, then 6 plus 2, I get positive 8. Okay, 8 times 1, I get positive 8 here, so I add it here now. Okay, positive 8 plus negative 8, I get 0. So mean that now I'm solving what? I'm solving 1x squared, okay, plus 6x, and then plus 8 equals to 0. What are the factors we said? We have x plus 2, okay, and then x plus 4, equals to 0. So what are my answers now? I have x equals to what? From here, x equals negative 2, or x equals negative 4, or the first one which was x equals to, here x equals positive 1. So these are my roots here. I hope we are together. And then our last example here, lastly, which we have, says that I am solving this one here. If you check here now, what do we have? The factor, the root is positive 2. I'm going to put positive 2 here. I'm going to put positive 2 here. So this is positive, because this is positive 2, I'm going to put it here. Okay, positive 2. So what are coefficients here? I've got positive 1 for x cubed. Okay. What about x squared? It does not appear, so I'm going to put 0 for x squared. Okay. Then x, I've got minus 5. Okay. I've got plus 2 here for the constant. Okay, positive 2. So we say the first one, bring it the way it is. The positive 1 here, bring it the way it is. So 1 times 2, I get 2. I'm going to say plus 2 here now. So plus 2 here. What's 2 plus 0? I get 2. I get positive 2. Then 2 times 2, I get 4. Then you say plus 4 here. Plus 4 here. 4 plus negative 5, I get negative 1. Negative 1 times 2, I get positive 2. So please see, I get negative 2. So I'm going to say negative 2. Plus 2, I get 0. So now I'm solving what? I'm solving 1x squared. Okay, 1x squared. Then plus 2x. Okay. And then minus 1 equals to 0. Now this one here, it's my quadratic, and I don't have the factors for this one because it's the negative 1 here, so I have to use quadratic formula. And when I do so, I'm going to get my x equals to what? I'm going to get my x equals to negative 1. Use quadratic formula, equals negative 1, and then plus or minus root 2. Okay, so I have these answers here. What are they? Let's write them down. It means our x values, our x-intercepts, which we have here. These ones here we have, and these ones here. What was the first one initially? We had it as x equals to positive 2. This one here. So x equals to positive 2. That was our first answer. X equals to positive 2. What else? X equals to negative 1 plus root 2. What about the other answer? It is x equals to negative 1 minus what? Minus root 2. So these are the answers here. So thank you so much for watching. We have to stop here. Try out these questions here. And note that you can come and attend at Alros Technology in person, or you can attend online, or you can attend both. So it's the same price. Just inbox me for more information. So try this activity here, and this activity 2, try it out as well, and activity 3, try it as well. Now regarding video 1 and video 2, do these questions here, try them out in your class workbook and bring them for marking. Yeah, try this question out, try it out. I'm sure for what we have discussed, you can attempt this question, try it out. Yes, it ends here. Yeah, thank you so much for watching. Once again, my name is Patrick Kamala. I am a tutor and educator for mathematics and physical sciences at Alros Technology Polokwane. Catch you in my next video. Bye bye.